little bit of history on this workstream. Back in the early days of Mojaloop, for reasons of efficiency and cost and convenience, most of the early development of the Mojaloop software happened in public cloud. Many of you will probably know that this is a very common pattern. It means you don't have to invest a huge amount of money in servers and machines to develop your software. You can simply rent some time on somebody else's machines in the cloud. However, as Mojaloop has matured, it's become more and more obvious that the environments in which people are operating Mojaloop are quite closely controlled by regulation, which means the software and the data that's collected and processed and stored by that software has to be held within country boundaries, within country borders. Typically in private data centers. So we have been focusing over the last year, I would say, on evolving and developing elements of the Mojaloop deployment stack to target private data centers. And we have successfully deployed into private data center since the last report out. So that's some big news there. We have successful on-prem deployments, on-premises deployments. We are continuing to evolve that capability with feedback from our adopters who are using this new capability. Thank you very much to those folks. A quick recap of our objectives. We would like people to be able to start small with Mojaloop and not have to make a massive investment in infrastructure, but be able to expand their capacity as their market size increases, the number of transactions they wish to pass across a Mojaloop scheme increases. We believe you should be able to add capacity in small, cheap chunks. So the principles we follow, the architectural patterns that we follow with our infrastructure are geared towards that type of growth. Obviously, Mojaloop is open source. We don't want anybody to have to depend on license fee technology in our stack. It's one of our core principles. You should be able to use Mojaloop without having to pay license fees to anybody. So you will not find any license fee software in our deployment stack for on-prem or cloud for that matter. However, we don't preclude people from doing that. If you want support from organizations that provide enterprise quality support or some particular enterprise versions of some of the components in our stack, you're free to do so. Financial infrastructure is very critical for a number of reasons that I won't go into, but we take this responsibility very seriously as a community. So all of our efforts are focused on making sure we have carrier-grade security, reliability, and resilience in everything we do. So many of the patterns and practices that we employ are firmly following those principles. Some highlights since the last report out. Our secure OS layer, the Kairos immutable Linux. You will have heard our good friends in Rwanda talking about how they're using that for their on-premise deployment. They're continuing to test that. We're very grateful to for their help. Thank you, guys. Your help is very much appreciated. The self-serve documentation for the infrastructure as code modules, it has been produced and is being iterated. Again, adopters are using that documentation actively now. We're taking feedback from them and we'll be incorporating those enhancements and changes as soon as possible to make that process easier for the next people that come along. Since the last report out, we've enhanced the monitoring stack that you can deploy in on-premise. Those of you who are familiar with public cloud will know that very often you get a lot of monitoring components for free. If you create virtual machines or databases in the cloud, They tend to provide you with tools that allow you to monitor how those components are performing. It's a little bit more complex in the on-premise world. You have to do those things yourself. So we now provide off-the-shelf components that allow you to build a comprehensive carrier-grade monitoring stack with application health metrics and a set of default dashboards to get you started. This next point on the slide, we have replaced WSO2 components with Istio. We did announce that at the previous report out, but it's so significant and important, I'm going to reiterate it. Istio is a cloud native, well, I'm not going to say cloud native actually, I'm going to say Kubernetes native API gateway and service mesh solution. It's a generation ahead of WSO2, so that's a significant evolution of our stack there. Backing that, we're using some off-the-shelf open source standards compliant identity and access management solutions, Keycloak, which is very commonly known and used, and the Ori stack. We have some work in progress still, eliminating the last few remaining cloud dependencies in the control center part of our on-prem deployment. So at the moment, the control center, that's the software package that allows you to manage your modular loop installations. That still has a couple of cloud dependencies, DNS and object storage, for example. At the last community meeting, we asked if people could come and help us with that. Infotex have stepped up. Thank you very much, guys. And we're almost done with that. When we have done that, we will be able to do a fully air-gapped on-premise modular loop deployment. We're very close to that. So at this point, I'm going to hand over to David to take you through the next part of our update. Thank you, David.
Hello, everybody. So I'm just going to take it back to the slide again. I'm going to try, and thank you, James, for the good introduction to the work that we've been doing. I want to say that everything that I'm going to present here works in the cloud and on-prem. So the idea from, I'd say, the last year is to make a cloud agnostic version of the code base, the infrastructure as code, in order for us to have one common set of components that we can deploy on any cloud, including on-prem. So having said that, what I'm going to highlight, and I'm going to try to do it fast because I'm going to try to get through a few of the items that are on this list. And I'm also going to try to have Musamil, who's on the line, talk about the monitoring stack improvements. So we're going to touch on WSO2 as well. First, I'm just going to hit on the node affinities and the taint toleration support for workload segregation. So one thing that you find, especially when you're working on bare metal, is that you need to allocate workloads much more carefully than you do in the cloud. So the first item is just to announce that we have that support. It's configuration driven within the IAC. And what this means is that you can allocate workloads, certain pods, to certain VMs, if you want to call them that, nodes within the Kubernetes cluster. And that allows you to create nodes that are particular, say, to databases, nodes that are particular to modular loop services, and then make sure that your workloads are only running on those nodes. So that's been tested on bare metal as well as AWS, and that's functioning as expected. Okay, so the monitoring stack update. I mentioned I'm going to try to get through this quickly. So what we had before with the monitoring stack is that we moved away from using Elasticsearch and EFK for many years now. And we've used the Grafana stack, including Loki. And we had decided to go with Loki stack as a one master chart that allows you to deploy Loki, in addition to Prometheus and Grafana, as our base stack. And we also had open source and Mojaloop donated different dashboards that were pre-configured as a part of that installation. So what we ended up finding was that this number one, that stack, was not being updated quickly. We couldn't use the most recent components. And so we decided to move to an operator approach. And that's what we're going to demo today, is the operator approach for Prometheus and Grafana, which allow you to use custom resources in order to, excuse me, get some water. In order to configure your dashboards and your scraping for Prometheus. So here we have an account lookup dashboard as an example. And again, these dashboards can be configured by the application that is being installed, as opposed to being configured as a part of the monitoring stack itself. So this shows a Mojaloop account lookup dashboard. And this is for people who like YAML, the custom resource definition that is configuring this dashboard. And this gets deployed with Mojaloop. It doesn't get deployed with the monitoring stack. And here we have a log view. This is Loki that allows you to do queries on your log data. And again, this is using the standard Promtail component from the Loki stack. So do we have Musamil online?
Yeah, I think I'm here. Can you guys hear me? Hello, can you hear me?
Yes. Hi, Musamil. So I'm going to hand it
Hi.
over to Musamil to talk about how do you add new services to this monitoring stack. So take it away, Musamil.
Okay. Yeah. So hi, my name is Muzammil, and I've been working with David. Both of us have been, I think, working for some time now, primarily on the monitoring stack, and most of it is now up and running. And most of my work has primarily been relating to the monitoring infra. David, can you go to the next slide? Yeah. So before we jump into how we can add more services and we can monitor them with our existing infrastructure, I just wanted to take a quick look at it. So as a user, you only interact with Grafana and you have access to all the dashboards. David shared a sample of that before. And Grafana behind the scenes, it talks to Prometheus, and Prometheus in turn scrapes the metrics from different services. So if you're a developer or if you're someone who is adding more capability to Mojaloop and you have your own service and you want the services, you want the metrics for your services to be scraped and you want it to be shown on Grafana, then in order to do that, we have to integrate our services and get them scraped by Prometheus. David, can you go to the next slide? Yeah. So the way we wanted to make it is that as a developer, it's relatively easy for you and we do most of the heavy lifting for you. So over here, you can see that within the Mojaloop namespace, we have this file called service monitors. And this file is already responsible for monitoring a lot of existing services. So what you have to do is you need to add your new service into the existing list of services. And from that point onward, Prometheus is going to take care of all the scraping part of it. But you just need to make sure that you name your ports properly. The port where you expose your metrics, it should be named HTTP. We don't have any restriction on the port number, but it should be named as HTTP. And that's it. From there onward, Prometheus should be able to scrape your metrics and store them inside its time series database. David, can you go to the next slide? Yeah, and this is a sample I wanted to have just to make sure how we can be sure that Prometheus is actually scraping our metrics. So if you look over here within the Prometheus targets, we have this Mojo Loop Service Monitor, and over here we have all the different targets defined with the Mojo Loop Service Monitor. And over here you want to look into this service tag, and the new service that you added, it should be over here. And if it shows up over here, it's an indication that Prometheus knows about your service and it will be able to scrape metrics from it. And this particular UI, this is also going to give you a basic idea about the state of your scraping. So if there's something wrong, it should show up in the error box, and it should also show your state as other than up. That way, you know things are up and running for your service. David, can we go to the next slide? And once we have all the metrics being transported over to the Prometheus, we want to show them, we want to visualize them on a dashboard. And in order to do that, we need to add a custom resource within our Kubernetes infrastructure. And the way to do it, we already have a few examples. We just need to copy one of them, and we just need to update the URL to our dashboard. So the dashboard has a backing JSON. It's a simple JSON document. We can host it on any website. We can host it anywhere, maybe a GitHub. And then we can just take the link and put it over there. And then from that point onward, the Grafana operator is going to take care of reading that dashboard JSON, and it's going to properly populate that within the Grafana installations that you have in your cluster. And you will be able to get access to your dashboard, and then those dashboards will be able to communicate with the Prometheus, and you will be able to get all the metrics related to your new services. David, I think that's all from here. We have been able to add new targets to Prometheus, and we also added new dashboards to Grafana. And I think that should be good for most of the work. David, do you want to go on?
Sure. All right. Thanks, Musimo. So just to recap, now what we're doing with the GitOps approach is we're creating YAML files for the most part, including files like this for dashboards and for the scraping of the different targets. Those are included in the application deploy. And then, can I get the presentation back on the screen? Thank you. So then it is, Grafana is also configured with OIDC in order to be able to allow for a single sign-on using GitLab credentials. So once the deployment is finished using Argo as the GitOps operator, then you can log into Grafana and then you'll be able to see your different dashboards in this way. So I am going to go through the next two slides. And then quickly, I want to talk about another item for this PI, which was we had a finance portal that was in the previous version of IAC was deployed using WSO2 ISKM in conjunction with custom resources in order to provide access to finance portal. So as James mentioned, WSO2 is out of the equation now. We're using Istio and Keycloak. And what we did this PI is we were able to take Finance Portal, do some refactoring of some of the services within Finance Portal to separate them out, make them reusable. And now we have a reusable platform for providing access control using Ori Stack and Istio and Keycloak for all the portals. And so the portals that we've tested this on are Finance Portal and as well as Connection Manager. And I'm just going to talk quickly about how this is configured now with this new approach. So first of all, if we compare what are we getting with Istio versus WSO2, obviously WSO2 was a monolithic server, and it consumed lots of resources, and it required lots of configuration files that we weren't even using. So we weren't using many of the services that WSO2 provided, but we still had to configure them and run them. And also, ISKM was the only identity management solution that we could really configure WSO2 to use. With the Istio stack, it's using an operator approach. So again, everything is custom resource based. And that means that we can add Istio components on an application by application basis. And that allows us to separate concerns, application stack concerns from the operator. And it works with any identity management solution. So in this case, we're using Keycloak. I'd also add that Istio provides egress gateway control that we're leveraging now instead of using HA proxy that we used to use for callback traffic. So the components from Istio, I just mentioned the egress gateway, the ingress gateway, which is controlling traffic coming into the cluster. Then we have authentication and authorization by the business ops framework. And then the identity server is Keycloak. So we have UI portals and experience API services, as well as the connection manager APIs and the FSP IOP APIs that are all access control governed by the set of services that you see on the left. And this is the diagram of the new, let's say, dependencies between components. And you'll see an example of the payment manager on the left-hand side as a DFSP that is interacting with the system. And you also see on the bottom left UI portals. And here we have the finance portal UI and the connection manager portal UI that are interacting with the Istio internal gateway. And you also see that the payment manager as a DFSP is accessing the external gateway of Istio. And then on the right-hand side, you see the business ops framework and Keycloak that are interacting in order to provide authentication and authorization services. So the business ops framework is essentially a service that the Istio external gateway is calling in order to determine whether the user has the appropriate access for that service call. And then on the top, you see callbacks coming from a Moduloop core service that hits an Istio sidecar proxy that is running in the same pod as the service in question. And that handles the callback, and that callback gets routed to the egress gateway, which then uses the mutual TLS that's configured for that DFSP to make the callback. So that configuration is self-contained, and the Moduloop core services don't have to be configured with that mutual TLS on an application basis. And then the last thing to say would be connection manager in the middle, near the bottom. It does the onboarding, and the onboarding now consists of creating multiple custom resources for each onboarded DFSP. And those custom resources create the rules, destination rules, as well as creating the client certificates that are used by the switch to call. And all of those custom resources are generated from Connection Manager and then deployed into the switch. And then from that point on, it's completely taken care of by Istio. So that is the deep dive into the new access control framework. So if we look at an example workflow of how you would use the business ops framework within the context of what I just explained, we would have the first step is you define the roles and the permissions through configuration files. And those are stored in the GitLab repo for an environment and then are deployed as YAML by the GitOps operator. Then you would protect a backend endpoint with a permission And this is happening in Istio. And then you create users in Keycloak. You go into Keycloak, create a user, and then you assign roles to those users. And those roles are not in Keycloak. Those roles are in the business ops framework. And then users log into the portals, and then they can only access the APIs or the UIs that are basically the APIs that have been configured in the previous 4 steps. So that's it for me. I'm going to hand it back over to James.
Thanks, David. A lot of work been done there. Thank you very much. So next steps for this work stream. What have we got left to do? Well, this is an ongoing process. In the short term, we need to finish off just removing those last few cloud dependencies from the control center so we can have a fully air-gapped GitOps modular loop deployment. We are continuing to iterate the documentation, the self-serve documentation. Our North Star is for anybody to be able to come along and use these tools, use this whole tool chain to deploy production grade modular loop switches on premise or in the cloud for that matter. In the meantime, and something that's likely to continue for the foreseeable future, the members of this work stream are actively supporting adopters right now with their on-premise deployments. We're helping them with resolving issues. Not that there have been that many issues so far, and we will continue to do so. We are available as people come and use modular loop and they deploy it in their own data centers. Members of this work stream are available to support you. Is there one final slide? Yeah, there we go. Simeon asked for some memes. That one's for Simeon. Thank you very much, everybody. Everybody who's contributed. Special, yeah, thank you. Special shout out to the teams in Rwanda, RSwitch and Wiredin, who have been contributing greatly to this work stream. Thank you, guys.